We are going to demonstrate the basic surgical starter kit, and we're going to be placing a 5x8 implant. I'm here today with Selene from Argon Dental.
Hello everyone.
Selene's going to help me demonstrate the surgical kit, and we're going to go tool by tool, so by the end of this video you should have a good understanding what each tool should be used for. So we're going to start in the upper right hand or upper left hand corner of the surgical tray. The first burr that we are going to demonstrate is the burr, it's a number 8 round. What a number 8 round burr is used for is to create a purchase point for the 2mm pilot drill. What this helps and aid you with is creating a purchase point so that your 2mm pilot drill does not walk across the bone. So what we're going to do is demonstrate here the surgical drill on some bone, and we would go no more than 600 RPM. You would press just enough to create just a small purchase point in the bone, as Selene demonstrated. The next burr we're going to demonstrate is called the starter burr. The starter burr is used for a very similar fashion as what the number 8 round burr is used for, but as you see, it's much pointier. This is used in a situation where you would have a very sharp or pointed ridge that you're trying to create a purchase point for. And as you can see, the ridge that Selene is going to demonstrate on it, it's much sharper and much pointier. So you would also use this burr no more than 600 RPMs, and it would create a small purchase point, but it's very sharp, so it kind of finds its own area in the bone to drill into, and it doesn't walk across the bone. The next burr that we're going to demonstrate is called the extension. The extension is used in a situation where we would have 2 adjacent teeth and we're drilling an osteotomy between those teeth, and the length of the typical burrs are not long enough, so the surgical motor might hit the adjacent teeth. So as you can see, where Selene is demonstrating is she just grabbed any random burr and she put it in the extension. As you can see, it really made it quite long so that you can reach much deeper into areas where natural teeth might get in your way. And again, the extension can be used with any of these burrs that have the contra-angle or latch grip type connection that is in the surgical kit. So now that we've created a purchase point in the bone, we're going to go to the 18mm pilot drill. The 18mm pilot drill has black markings on it, as well as all of the surgical drills in the kit. And as you can see on the plastic surgical tray themselves, there is a black line and a demonstration of that burr. So we can show the depth that you would drill to. So the bottom line is 5.5. The top of the bottom line is 6.5, then it goes 7.5, 8.5, and so on. We're going to demonstrate how to place a 5 diameter by 8 length implant. So with Argon K3, we know it's a subcrestal placed implant. So we are going to drill 8 millimeters deep, plus 1 more millimeter deeper because we want the head of the implant to be below the crest of the bone by 1 millimeter. So 8 plus 1 is 9. That's going to be our total depth. So we are going to drill to the bottom of the 3rd black line on the surgical drill. So Selene is going to demonstrate drilling the osteotomy to the bottom of the 3rd black line. And again, we are only going to be utilizing this at 600 RPM and no greater. These drills are a 4-fluted surgical drill, so they do drill very rapidly. Therefore, we don't need a lot of RPMs to make the osteotomy. Now that we've created our start of our surgical osteotomy, keep in mind that the pilot drill is an end cutting drill. So it is used to drill the osteotomy at full length. So we did drill 9 millimeters deep, and we will not need to go any deeper than that for the implant we're going to be placing. All of the surgical drills we're going to utilize from here on simply are going to widen the osteotomy to the width of the implant that we're going to be placing, which is a 5. So the next drill she's going to demonstrate is a 3mm diameter surgical drill. So we went from a 2mm pilot to a 3mm surgical drill, and we are still only going to drill to the bottom of the 3rd black line, which is 9 millimeters deep. Again, RPM is 600. And you can see how quickly the osteotomy gets drilled because the purchase point or the pilot drill's already been drilled at 9 millimeters deep. All we did is widen the osteotomy 1 millimeter from 2 millimeters to 3 millimeters wide. Now, if we were placing a 3 millimeter implant, we would stop right here and we would place a 3 millimeter implant. But we're not. We're demonstrating a 5 millimeter diameter implant. So we're going to continue to go up to a 3.5 diameter surgical drill, again at 600 RPMs, drilling to the third black line. So now we drilled to a 3.5 diameter, we're going to go up to a 4.0 diameter drill. Again, to the bottom of the third black line at 600 RPMs. The next drill we're going to be using is a 4.5 diameter drill. And again, if we were placing a 4.5 diameter implant, this would be our final drill. But we're going to demonstrate the 5.0. 600 RPMs, bottom of the third black line. The next drill we're going to demonstrate is going to be the 5.0. Now this is going to be our final drill since we were placing a 5 diameter implant. Selene again is going to demonstrate that we are going to drill to the bottom of the third black line, which is 9 millimeters in depth. One thing that is good to note is the shank of each drill has a colored stripe. And as you can see on this drill, the 5 millimeter drill has a green colored stripe which matches the green grommet. The yellow 4.5 drill on the shaft is going to show a yellow colored shank to match the yellow grommet. This makes it easy to make sure that you orient the proper drill diameter into its proper location. At this point, we have completed the osteotomy for the proper depth, which is 9 millimeters deep to place an 8 millimeter implant, and the proper width, which is 5 millimeters in diameter. At this point, the doctor needs to make a decision on the quality of the bone. If you had very dense D1 type bone, you're going to need to use the tap and the sinker. And at this time, I will demonstrate that. You would not, and it's good to note that you would not need to ever use the tap in very poor quality bone, as the implant will go ahead and compress the bone as it's inserted into the bone. But since this is a very dense boning, we've classified this to be more of a D1, we're going to use the tap. The tap pre-cuts the threads of the implant in the bone. Again, there are lines that are placed on the tap to show you the depth that you would be tapping to. Quite often, we only tap half to 3/4 the length of the implant. So if we're drilling an osteotomy that is 9 millimeters deep, we only want to go roughly 4.5 millimeters in depth to go halfway. RPM for the tap would be 20 RPM and no greater. You can use the reference of the lines again on the side of the tap so you know the depth to drill to. Selene will demonstrate the tap at 20 RPM, and you'll notice how slow this does screw in because it's cutting the bone as it's going in. It's pre-cutting the threads for the implant to be placed. Light pressure and the implant tap should pull itself right down into the depth that is needed. It is important to note that when you are fully down 3/4 or halfway down the osteotomy with the tap and you want to take the tap out, you must put the motor in reverse and back it out, and it will automatically unthread itself out of the bone. It's important to note, do not pull it out of the bone or you will strip the threads that you've just cut in the bone. You will strip them out, and now we have a problem. The next tool we're going to utilize will be the sinker. The sinker is also utilized when you use the tap. The cutting threads of the tap are on the very top part of the burr. As you see, it's just a bullet shaped and rounded. You would insert that into the osteotomy. Again, very slow RPM of 20 RPM, and it is going to cut just the top cortical part of the cortical plate. What this does is it allows the implant to go past the hardest part of the bone so you don't get any binding at the cortical plate. Very slow RPMs of 20. Now we have completed our osteotomy. We went from a 2.0 pilot and sequentially went up to a 3, 3.5, 4, 4.5, and 5.0 is where we stopped. We drilled 9 millimeters deep, and we stopped at a 5 diameter drill to place a 5x8 implant. At this point, we're going to demonstrate how to place the dental implant. At this point, we're going to take the implant out of the box and show you the carrier. This is the implant carrier, which you'll unscrew the cap, exposing the dental implant. This is a sterile environment. You should be working with gloves. We're demonstrating this right now without gloves, only as a demonstration video. To place the implant, you're going to grab the yellow inserter, which is the 3mm or the short implant inserter. Put that in your drill or your torque wrench. You will seat the hexagon into the dental implant until the black line disappears. We do have a separate video of how to pick this implant up in high definition in our other video series. Now that you have the implant picked up on the inserter, you can place the implant. We recommend placing the implant at no more than 20 RPM. As the implant goes down, you will be placing the implant at a max torque value of 45 Newton centimeters. If you do reach a max torque of 45 Newton centimeters and you are not at full depth, make sure that you either back the implant out by a millimeter or two and put it back in forward, or take the implant all the way out, go back and re-tap the osteotomy so that the implant does seat at full depth, which would be 1 millimeter below the crest of the bone. When the implant is placed, it is important to note that the implant is 1 millimeter below the crest of the bone at the lowest point. If you see any threads exposed or any area that is sticking out of the bone, it is okay to put the implant deeper. At this point, we're going to demonstrate the cover screw and what tools in the basic surgical kit to utilize to put the cover screw on. All K3 implants come with a cover screw on the cap of the carrier. In this situation, you'll note that the cover screw is yellow. The reason it is yellow is it is a 3 millimeter internal connection. Our other implant diameter is a 2 millimeter internal connection, which would be red in color. We also have a short implant that has a blue cover screw. It still has a 3 millimeter internal connection, but it has a different thread design since it's a short implant, so the cover screw would be blue. To insert the cover screw, you want to go back to the surgical kit and grab the hex 1.2 millimeter screwdrivers. There are two in the kit. One of them that Selene is demonstrating has knurling on it for a hand driver. In this situation, that's what we're going to demonstrate. You will unscrew counterclockwise the cover screw from the cap and insert it into the implant and hand tighten. The other tool we have in the 1.2 hex screwdriver is a contra-angle or latch grip design, in case you would want to use the cover or the motor to put the cover screw on. It's also important to note that a 1.2 millimeter is also a 048 style driver. The 1.2 millimeter screwdrivers would be utilized in all prosthetic components. So once the implant is placed, whether it's a cover screw, a tissue former, a temporary abutment, or a permanent abutment, all of those cases you would use the 1.2 millimeter hex driver to insert any prosthetic into the implant. The next two tools we're going to demonstrate is going to be the ISO adapter. The ISO adapter is utilized to take a latch grip or contra-angle connection and turning it into a ratchet connection. So where would you want to utilize this? Let's say you want to use the 1.2 hex driver that has a contra-angle and you want to turn it into a latch grip. You would insert the ISO adapter, as Selene is demonstrating, until you see the top. You rotate the 1.2 hex until it kind of pops through the top of the driver. Now you notice there's a square ratchet. So where would you use that? Underneath the surgical kit, you'll notice a torque wrench. That torque wrench is what is adapted to a square ratchet driver. So you note the square on the torque wrench, you would insert the ISO adapter. You now just turned a latch grip or contra-angle into a ratchet connection in case you want to use the torque wrench to torque down an abutment. And in this situation, you would never torque down a cover screw, but just demonstrating that it can be utilized with a torque wrench. The next tool we are going to demonstrate is the ratchet extension. The ratchet extension simply extends the ratchet connection longer. Again, similar to the other extension we demonstrated, it just gives you more length in case you need to avoid long teeth in an area where you would drill an osteotomy or you have one tooth on either side. As you can see, it makes the ratchet much longer, getting above those adjacent teeth. The next tools we're going to demonstrate is the abutment removal tool. The abutment removal tools, as you see in the far left, there's a red, a yellow, and a blue. The red is utilized for the 2mm internal connection implant, which would be the 3 diameter and 3.5 diameter implant. The yellow abutment removal tool is used in the 3mm internal connection, which is our implant series 4.0 diameter up to the 8.0 diameter. The blue is used for our short implants, which would be the 5.5, 6.5, and 7.5 lengthed implant. In this situation, we placed a 5x8 implant, which would be the 3mm yellow internal connection. We've preset the model up with an abutment on to demonstrate how to utilize the abutment removal tool. So Selene is going to grab the 1.2mm hex driver. She's going to remove the yellow abutment screw from the abutment. Once the screw is removed, she is going to grab the yellow 3mm abutment removal tool, insert it in the same location that the abutment screw came out of. It is important to note there is a number 3 on the abutment removal tool indicating it's the 3mm internal connection. She's going to insert it where the abutment screw came out, and she's going to screw it in clockwise. It's going to screw in very easy. Once it meets some resistance, that means it has reached the bottom of the implant. You will continue to turn it. It will slowly screw the abutment out of the implant. Once you take it out of the mouth, you'll notice the abutment is screwed on the abutment removal tool. To remove the abutment, you would screw the abutment removal tool counterclockwise, which will unthread the abutment removal tool from the implant abutment. At this point, you have successfully went through every tool in the basic surgical starter kit. For more videos and product information,